Good morning, all. The paper titled Community Detection Based on Random Algorithm in a Social Network. The authors are C. Suganthini, Dr. R. Bhaskaran, D. Divya. The agenda: Introduction, Objective, Related Work, Proposed System, Results and Discussion, Conclusion, and References. Introduction: In a social network, the communities consist of a group of friends or a family members or a colleague or an interest based on the group. These groups are, in general, we can identify it as a community. Basically, they form a similar interest based on the groups, where it can be identified as a group or a cluster of nodes within a network that are more densely connected. Then the nodes outside the network are sparsely connected. So the communities are into two groups. We can call it as an intra-community structure, where we'll have the number of nodes within a community are more. The other type we can call it as an inter-community structure, where we'll have a different more number of community structures that form different. There are two types of community detection. One is overlapping and the other one is a non-overlapping node, where the overlapping node which belongs to the particular node which belongs to exactly one community, that we call it as a non-overlapping node, where the overlapping node we will call it as a single node which belongs to more than a community, that will be called as a overlapping node. Here the community detection algorithm uses the local and global method, where the structural informations are extracted, and the community structure is derived based on the structural similarity with the evaluation functions such as the modularity and the NMI score, normal mutual information score. The objective of the work is mainly to identify the base community structure along with the global and local information model, and to obtain a high quality level of a community structure and the similarities. The algorithm mainly focuses on either the structural based similarity or else the attribute based similarity. Mainly it deals with the component of the node which is connected within a network. And the next is to obtain an independent size, which mainly deals with the large scale of a network. We'll call it as a complex network. These are the main focuses of the work. Literature survey. First author, David et al. Propose the method local community detection based on the high importance node ranking algorithm. The other method is community detection based on structural similarity algorithm. There is the issues here is the evaluation function need to be used for selecting an appropriate merging component, and the overlapping community structure is not identified in this. It is not suitable for the large scale, only for the small scale network it will be suitable, this method. The second paper deals with the method local community direction on a high importance of a node ranking, where the issues here identified are the initial extraction of a community is high for the larger data set. It works only for the non-overlapping communities. The third paper, the method used is approximation ranking method, and the next is a network partitioning method, where the issues in this is the shortest path calculation between the potential node consumes longer time, and the performance level based on the structural and the robustness of the node is very low when compared to the synthetic network. The next paper, the methodology used is inference percolation method, as well as depends on the linear threshold and the independent cascade model, where here the issues are this method does not focus on the decays in the influence process, where only 50% of overlapping node is found in the communities, and the influence on the direct node of the network is partially found. And in the next paper, the method used a linear threshold model, where the issues identified are it has low modularity function value, and it is not suitable for finding in non-overlapping communities. Where here it identifies the structural based similarity and it avoids the attribute based similarity. In the next paper, the methodology used is the evolutionary multi-objective algorithm. And the next method is the fuzzy means clustering. Here, the issues identified is it does not support the larger scale network, where non-overlapping communities takes more time than the overlapping community prediction. Followed by it, a proposed system where the community prediction is based on the algorithm called the random algorithm is proposed in it. The name called it is a community prediction based on the random algorithm, which is identified for the complex network with the additional evaluation used for deriving the best community structure. Where here we can identify the sparse communities which are separated in order to maintain the high quality network structure, and larger scale data is used to compare the real and synthetic network for the performance measure. With the similarities of the attributes are measured based on the focus of the local and the global network information. Where here we will identify the communities based on the randomized algorithm. So the algorithm proposed here, we will call it as CDRA, that is community direction based on the randomized algorithm. And this is the overall architecture. Where here we have four levels of modules which is present in the proposed work. Where the first level is the pre-processing, the next is the node identification, the third level is the intra-community structure, and the fourth is the inter-community structure. Where the first, in the pre-processing, we'll identify the module name as a weight assigning unit. Where here we'll assign the weight for the node and the link based on the assigning of the weight. Here the similarity measurement is calculated based on the weight assigned to the node as well as the link. Weight assigned to the link, and the information is stored in the database. And the next module is in node identification. Where here the component facilitates the creation of a key communities where the merging communities are done. So initially it will select an unselected node, and from that it will evaluate the node based on the weight component which is previously identified. From that it will create a new community and it will update towards the existing community. Based on this, the community similarities are gathered in a database. And the third module is the intra-community structure, where the main logic here is we find the nodes within a community, how similar are it is based on the two components. One is the merging unit, the other is the selecting unit. But based on the merging unit, it helps in improve the evaluation function and increases accuracy compared to the existing methods. And the selection unit chooses a suitable pair of communities as its potential candidates for merging, and it shows the primary community structure. Where the third module gives the output as a merged communities. And the fourth module is the inter-community structure, where the nodes are identified between different communities, where it chooses the most optimal community structure produced by the component which are responsible for the merging unit. The community direction process selects the community structure with the highest value. And the overall output produces the prominent community structure. In the pre-processing, the input used is the number of nodes in the edges, whereas the output extracted is the network structure based on the weight and the similarity measures. And in the node identification, the input is from the previous module. So the network structure is given as the input and it forms a community structure with a high quality. And in the intra-community structure, the input given is the community structure from the previous phase, and it forms the output as a merged communities based on the merging unit and the selecting unit. And in the fourth model, inter-community structure, the input given is a selected pair of a merged communities, which is given as an input, and the output predicted here is the prominent communities which are identified. And the results and discussion, the data set description which I used is a three network, Dolphin network, CDBRA and political book. Under the Dolphin network, we have 62 nodes and 159 edges. Edges represents the relationship between each nodes. And the CDBRA, it includes 34 nodes, 78 edges. In political book, it includes 105 nodes and 441 edges. And this is the initial network structure which we formed in the second model based on the algorithm of the community direction, based on the randomized algorithm, based on the proposed work, we have identified the community structure which are detected in the dolphin day Zagri-Karate club. And the performance measurement are calculated based on the modularity and the degree fraction formula. And at last, the enemy score has been calculated. The graph is plotted based on the modularity score, where the randomized algorithm, the proposed algorithm, is more efficient when compared to the other existing algorithm compared in among the three data set. The conclusion, the proposed community direction algorithm based on the randomized algorithm helps to detect the communities by considering both the local and global information in the inter-community structure, where the similar communities are identified from the different groups that are merged based on the node threshold in the different networks which forms a high quality structure of community. The best community structure was selected based on the density, modularity, and the NMI evaluation. The evaluation function used are calculated based on the both local and global network information in order to achieve a high quality community structure based on high accuracy. And the future work it deals to this work can related to further helps in identifying the network interaction and the influence of each node and node. And it also helps in identifying the network behavior and the understand the behavior among the different network as well as identifying the influential node. And these are the references which are used. Thank you all.